Now let us see how to find the position of a point with respect to a given hyperbola. So suppose that we are given the equation of some hyperbola, and we are also given the coordinates of some point. Okay. Now how do we decide whether the point lies on the hyperbola or inside the hyperbola or outside the hyperbola? So that is the position of a point with respect to the hyperbola. Now for that, what do we do is, again this is very much similar to what we did in ellipse. What we do is we bring the equation of the hyperbola in a form where all the terms are on one side and 0 on the other side. So therefore we get x square upon a square minus y square upon b square minus 1 equal to 0. Correct? And the expression on the left hand side we call as s. Now what we have to do is, in this particular expression, we have to substitute the coordinates of the given point, alright, and that we call as S1. Okay, so therefore here S1 basically refers to the value of the expression x1 square upon a square minus y1 square upon b square quantity, that is S1. And now lastly, based on the value of the S1, we decide where the point would be lying. So the condition is that if S1 is less than 0, then the point is lying inside the hyperbola. Now looking at the figure, it might be a little confusing, that is which portion we call as inside and which portion we call as outside. So the inside portion is that which is contained as shown here, that is within the two branches of the hyperbola. If S1 is greater than 0, then the point lies outside the hyperbola. Okay. That is the region which is contained to the left of the left branch or to the right of the right branch. And if S1 turns out to be 0, then it just means that the point satisfies the equation of the hyperbola itself. So that means the point lies on the hyperbola. Okay, so in this way we can detect whether a given point lies inside, outside, or on the hyperbola. Now let's solve one example based on this. Find whether the point 3, 4 is inside, outside, or on the hyperbola whose equation is given to us. Okay, so let us first calculate S1. In place of x we write 3, that is 3 square is 9, so 9 by 16 minus 4 square is 16 upon 25 minus 1. Okay, so that gives us, we have 16 into 25, so that turns out to be 400. In the numerator we have 225 minus 256 minus 400, and now you see clearly the numerator is a negative quantity, so therefore S1 is less than 0, so therefore the point lies inside the hyperbola, and by inside we mean the region which is trapped between the two branches of the hyperbola.